I welcome you all for my mathematics class. Today let us do some problems in permutation and combination, particularly permutations. So you see that what is a permutation? See, permutation is nothing but arrangement of things. For example, you have got n things and these things have to be arranged in r different ways. Then the number of such r permutations can be given by NPR. This is what we say. I will give you more explanation on this. If there are n things, let us suppose that you have got n things with you and there are r places. You are going to take the things and fill up the r places with n things. Now, how many arrangements are possible? That is the question. Now, that is NPR. For example, let us suppose that you have got A, B, C, D. 4 things are there and you have got here 3 places. And now that these 4 things have to be filled in these 3 places without that is each place has to be filled with a distinct alphabet here, not A, it is not like that. Repetition of the elements while filling is not allowed. Okay, no, that means if you fill up this place by A, the second and third place cannot be filled by A again. That is what repetition is not allowed. And here you see that when you go for such, now the question is, if I tell you that you have got n things, in this place you have got 4 things and or n things or places. Here in the place of r I am taking 3 places. Now the question is, how many permutations are possible? How many arrangements are possible? Now you see that you have got 4 things. This place can be filled in 4 different ways. Either you can fill it up by A, or you can fill it by B, or you can fill it up by C, or you can fill it up by D. That means what? There are 4 ways of doing that. Having filled this place by any of the 4 elements, here A, B, C, D, you are left out with only 3 other elements which can fill the second place. That means what? This place I will have only 3 remaining alphabets which can be put in this place too. That means what? As I told you, this can be filled in 4 ways, means now that you're left out with 3 alphabets, that this can be filled in 3 different ways. Okay, now having filled the second place, now this place has been filled in 4 different ways. 1 place has been filled. This place has been filled in 3 different ways. So 2 elements have been taken. Now you are left with any of the 2 other elements which can fill this 3rd place. So this can be done in what? 2 different ways. Okay. So out of the 4 ways, you may leave out 1 element. That is not our botheration. My question is, if you are going to have 4 elements in the place, here it is your n, here n, here it is this r places, 3 places. This is your r. N things, you are going to fill it up, put an arrangement with r places. That means the question, or permutations are possible. How many permutations are possible? The question is how many such elements. See how is it possible? Now you see that this can be given by, as I told you, if you have n things and if you're going to take r at a time, if you're going to what, make an arrangement for with r places or r things, so you see r places, so it is nothing but your npr, this is nothing but n factorial divided by n minus r factorial. I can derive this formula, but it is not required. So if it is required, I will definitely derive. So this is what n factorial divided by n minus r factorial. So what is that I have told you? What is that I have just now told you? If there are n things and you have r places, if you are going to arrange your n things in r places, then how many such possibilities are there? How many are max possible arrangements are there? If that be the question, the formula that you have to do is n factorial divided by n minus r factorial. Now let us come to this example here. Now here there are 4 elements, as I told you. This can be filled in what? 4 ways, and this can be filled in 3 ways. This can be filled in 2 ways. Now this is a product rule. This is a product rule. This work can be done in 4 different ways. This work, I make it very clear. The work of filling the first place, can be done in 4 different ways. And having done that, you are left out with 3 elements. So the second place has got 3 different ways of filling. So you see that the first 10 place put together can be filled in 4 into 3 ways. That means 12 ways are possible. So and the third one is you can fill it up in 2 different ways. So the total number of ways of filling the 3 places with 4 elements is the 4 into 3 into 2. That is equal to what? 4 into 3 into 2, that is equal to 12 for 24 ways. That means here what that you understand is, here you have got 4 places, 3 places, you are going to fill up with 4 elements, and that the possibility, the maximum, what I feel is the maximum arrangement possible is 24 ways. Now having studied, I have explained this part, I have given you a formula for doing it. This is called combination. See here, I will, what I want to tell you is that if you are going to manually go for filling the places, see for example, you take the first place as A. If you take this A, then this can be filled in B or C or D. And like that, you are going to make a 3-letter word like that, A, B, C. It may not have meaning, don't bother about that. If you are going to do this physically, that means what? Fill it up with A and go for all possible arrangements for the second and third place. Fill up the second place, so first place again with B. Go for all possible arrangements for the other 2 places. If this is continued, you will be writing 24 such words. That is no meaning, meaningless words you may write. So you see that you are going to write. See, it is not possible. Actually, it is not practically possible to write 24 A's. But I can definitely say that 24 A's definitely are possible. We may not be able to write, but if you are going to give now this particular work to a computer, now the computer is capable of doing not only this, it does a wonderful job. Even if you give big numbers, you see that it can give you the total permutations. How much ever the number be, it will be able to give. So you see that, but manually our human brain doesn't have that much capacity that I can say, but I can tell you how many possible words are there with this restriction imposed that each place must be filled only by distinct letters. Okay, now you see that this is can be filled in 4 ways, so 24 ways. I may not be able to write, but I am confident that it is 24 ways, 24 such permutations are possible. Now you see that this is so for which if you this is the one way, and if you are going to apply the formula here, what is the formula that you will apply here? In the place of n you have got 4, in the place of r you have got 2. So this is what is that you have got 4 3 places, 4 factorial divided by 3 factorial. What is 4 factorial? 1 into 2 into 3 into 4 divided by n minus r factorial. This is 4 minus 3 factorial. So this is 4 factorial divided by 1 factorial. 4 factorial is 1 into 2 into 3 into 4. Factorial 1 is 1. So you see that 24 ways are possible. Can you understand? So you see that now I am able to give a formula for the or permutations of n things taken r at a time. Can you understand? So this is the meaning of permutations. If I ask you another question, see this is with regard to, so you see that I will take like this. I am taking this A, B, C, D. I take again the 4 elements and ask you to go for collecting. Pick the elements. Pick the elements in whatever you want. Take 3. I ask you to take 3. Now you see that while you take whether you choose A, B, C or B, A, C or C, A, B in any way you want. Let us suppose that you have got 4 elements like A, B, C, D. You are asked to pick 3 elements, 3 alphabets from it, and you see that what is that you will do? Let us suppose that you like to take A, B, C. How will you take A, B, C? You will take A, B, C, fine. A, C, B, fine. B, A, C, fine. In whatever way you pick this A, B, C in random order possible, you see that you are going to take only A, B, C. Now you see that coming to this arrangement, I feel that I say that if there are n things and if you are going to take r at a time or you are going to fill r places, then you see that the number of permutations is equal to npr is equal to n factorial divided by n minus r factorial. So this is the understanding. Now let me come to the next one. See, so this is arrangement. Then you see that I go for, this is called permutation. Then I will tell you what is a combination. See, this is called permutation. So what is that? If there are n things taken r at a time is equal to npr is equal to n factorial n minus r factorial, that is equal to n factorial divided by n minus n factorial divided by n factorial. See here one example that I can give. No, you have got this place A, B, C, D, 1, 2, 3, 4. Now you fill this place, 4 places are there, and you are going to take 4, fill the 4 places, arrangement of 4 places with 4 things. That means what? This can be filled in 4 ways, this can be filled in 3 ways, this can be filled in 2 ways and 1. So this will be equal to what? 4 into, this is what? 4 factorial divided by 4 minus 4 factorial, that is equal to 4 factorial, that is equal to 1 into 2 into 3 into 4, that is equal to 424 ways. So you see that this is what happens when you take r is equal to n, that means factorial ways. Now let us suppose that let me take one more case in this. Let us suppose that you can, that is, you have got four places, and you can fill this place by, you can fill this by A, fill this also by A, this also by A, this also by A. You can fill this by B, this also by B. So you see that what happens is that this can be, you can fill it up in what? You can fill it up in four different ways. This also can be filled up in four different ways. This can be also filled up. That means what? Here you A, B, C, D, you can fill up the first place. Now then I don't impose any condition on the second place. The second place can also be filled by what? A, B, C. That means what? This can be A. That possibility. Then B, 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 C, 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 D, 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 D. Then all possible permutations. So there is no restriction imposed on this. As in the first case, I told you that distinct elements must occupy the places. But here I don't give such restrictions. I say that you fill up all the places with the same element, no problem. So you see that, therefore, if I this A, this can be filled in four different ways. The second place can also be filled up in four different ways. Third place can also be filled up in four different ways. So number of permutations is equal to 4 into 4 into 4. That is equal to what? 4 to the power of 4. So how many possible ways are there? 4 possible ways are 4 to the power of 4 possible ways are there. If there is no restriction as what? I allow you to go for repetition of elements. That is, a place can be filled by any one of the four elements. Every place can be filled by any one of the four elements. If that is the freeness given to you, then the total number of permutations is 4 to the power of 4, because this is 4, this is 4, this is 4, 4 to the power of 4. So this is another one that you must understand. Then we will come to the next one. See, we will come to what is just now. I will give you an idea of that. This is what is combination? Combination means, I just now a few minutes back I told something about, that is picking things. I told you simply by picking things. You got three, see, I will tell you this: A, B, C. I ask you to pick two elements from A, B, C. What is that you will do? Go for picking A, B, no problem. You take B, A, even that doesn't make a difference. Whether you take A, B or B, A, it is not going to matter at all. And if you can take B, C, C, B, no matter. And A, C, C, A. So you see that it is not going to matter at all. So you see that I ask you to pick two elements from a set of three elements. Then you see that you go for a combination. What is that combination? AB is a combination. AB is a BA is the same combination. It is not, in no way it is different from AB. Whether you pick AB or BA, the combination is, because I want a combination of two colors, red and blue, means whether I take red first, blue first, or blue first and red, it is not going to matter at all. So you see that here it is a combination. But in the case, but it is different from arrangements. It is different from arrangements. There in the arrangement, AB has got a, for example, if I say two elements, see 2, 1, I have got two elements like this, 2, 3, 4. 2, 3, 4. I tell you that you pick two numbers. You take this 2 and 3 and you take 3 and 2. It doesn't make a difference at all, because you are taking, I ask you to take two numbers. Pick two numbers. It is a combination. Combination means what? Take two elements. Either you take 2, 3 or 3, 2. It is not going to matter at all. But let me come to what is called your arrangement. I ask you to fill up the places, two places. I go for this 2, 3, 4. I ask you, I go take this 2, 3, 4. I ask you to go for arrangements. What is that you will do? If you give this 2 and 3, it is 23. If I put 3, 2, it has got a different meaning. So the arrangement has got a special significance there. So 2, 3 means it is giving a different number. 3, 2 means what? It is different. So that it matters. Your arrangement matters. Here the selection of elements mattered. But here in this combination, it doesn't matter at all. So you see that here in this combination, if you take this, it is not whether it is AB or BC, BA, it is not going to matter at all. Now coming to the my discussion on this. So you see that you have got three elements A, B, C. Select 2 at a time. Select 2 at a time. How many possibilities are there? How many ways are there? How many ways are there? Say manually doing, let me ask you this. AB is possible. BC is possible. Then AC. Is there any other way of selection? No, it is, you cannot do, because even you can go for CA means what? It is not a selection, it is the same as AC. So the select. So how many ways are there? So there are 3 ways. The number of ways is equal to 3. Okay. Now I have taken ABC. Let me say that you have got 10. 1, 2, 3, 4 up to 10. And I ask you to 10 any elements A, B, C, D, E, F, G, like that. Some 10 alphabets I take. I ask you to take 4 at a time. That means you go for a selection of 4 at a time. Now you tell me how many ways are there? It is not possible to say, because how many, this is, you have got small numbers A, B, C, so you can manually write on the board and you can count and say that these are the number of ways you can go for the selection. But if I have 10 such alphabets and I want to pick 5 at a time, now you tell me, is it humanly possible to do that? Computer can do. Even now I am telling you that computer is a wonderful machine that it can do. But our human brain, it can invent. It can go for invention of wonderful things, but it cannot do the wonderful things as a machine do. That is definitely not possible. I am 100% sure. Because you go for a big calculation, your calculator does, your computer does, but how far our brain does, it is very difficult. So we are capable of invention, but we cannot do as capable as a machine that has been given the knowledge of such big efficiency. It is given a big efficiency. So we cannot do that. So you see that this is not possible for me. But our mathematicians have given the method. They are given formulas. They are given formulas for such. They have experimented. They have done so many problems, and they have come out with a generalization. A generalization means a formula, like just like NPR you have got here. What is that formula which can give me to find the total number of combinations? That is, they have given. Now so that is called combinatorics. Combinatorics gives you the method of, here it is not possible for me. I cannot do that. What is that I cannot do? I cannot go for a big, finding the 10 alphabets are given, take 5 at a time. How many combinations are possible? That is very difficult. But what the mathematicians have given is, they are given a formula for that. Using that formula, within seconds you can get the result. Can you understand? So you see that is what these combinatorics are employed. Okay. Now let us come to this. Here you see that. So this is now what is the formula? Now I will give you the formula. When see if there are n things, selection of 3 things at a time. Therefore gives the number of combinations or selections is equal to NCR. We write it as what? N things taken or at a time. N things taken or at a selection of n things taken or at a time. The formula here is, see, you write this as n minus 1 divided by n minus r factorial. I will write this as r factorial. So what is that? This is nothing but the permutation of n things, n p r divided by r factorial. So this is, it has got so much of meaning in this that I will explain as we proceed. On this topic I will be doing more problems on this. So while I go on that, I will tell you how this particular aspect comes. That I will explain to you. Now you see that NCR is equal to n factorial divided by n minus r factorial into 1 by r factorial. This can be written as this. We know that n factorial divided by n minus r factorial divided by r factorial. Okay. Now you see that. Now let us come to this. As I given you this 3 things taken 2 at a time. It is, I have shown you that physically. I have shown you how we are getting this. Now apply this formula. What is that you will get here now? What is that you will get here? In the place of this you have got 3c2 is equal to what? 3 factorial divided by 3 minus 2 factorial into 2 factorial. So this is 3 factorial is 1 into 2 into 3. 3 minus 2 factorial is 1 factorial into 1 into 2. This and this will be NPR. N things taken or at a time is n, that is number of arrangements n factorial divided by n minus. That is n things, arrangement of n things taken or at a time. That means what? It is n factorial divided by n minus r factorial. NCR what? The combination, selection of n things from n things. NCR is equal to n factorial divided by n minus r factorial into 1 by here r factorial, that is equal to NPR divided by r factorial. And you must know that NCR is equal to NCn minus r. Prove that it is n r minus 1 plus it is nr is equal to n plus 1. See here n and r are positive. And n is greater than or equal to r. This is true because it cannot be, r cannot be greater than n. It is not possible. So these have to be some integers, positive integers, positive integers. Positive z. Z means set of all integers. Positive z. So you see that this is what we are going to do. Here this is nothing but this can be written as NCR minus 1 plus NCR is equal to n plus 1 CR. So the other meaning is, now you read this, n things, combination of n things taken r minus 1 at a time. This is combination of n things taken r at a time. if you are going to add this combination of n things r minus 1 at a time and combination of n things taken r at a time, then it will be equal to combination of n plus 1 things taken r at a time. So this is same as that. This is other way of writing. See this, you can either write like this or this can be written in this way. So this is also the other way of writing, nothing more. It is another way of writing. This is the normally you will find, this is how the books you can find in books, but this is also another way of writing the combinations. NCR means what? N things, combination of n things taken r at a time, like that. So this is what we will get, and let us now solve this, that is prove that. Now let me take this. Now I will take the n factorial divided by n minus r minus 1 factorial into r factorial plus n factorial divided by n minus r factorial into r factorial. So this is the right hand side. I will prove that it is equal to n plus 1 CR. So this is my RHS. This is my RHS. See, what I will do here is, here you must know that if I write this 1, 2, 3, 4, 5, this can be written as up to this is 4 factorial into 5. Or you can write this as 3 factorial, see it is 3 factorial into 4 into 5. In whatever way you express, it is the same 1, 2, 3, 4, 5. So keep this in your mind. What I am going to do here is that, see here you see that you have got here r minus 1 factorial. That means what? 1, 2, 3 up to r minus 1. Now you see that this is your r minus 1 factorial, and if I multiply this by r, then you see that this will become r factorial. What is it? Because r factorial is 1, 2, 3, 4 up to r. Before r it is r minus 1. See, it is up to r. Here before it is r minus 1. So you see that up to r minus 1 you can take it to be r minus 1 factorial, and there is one r left. Therefore r minus 1 factorial into r will be equal to your r factorial. This knowledge please have. So this is what you should understand in your factorial notation. So you see that now let me come to this problem here. Here you see that this is r minus 1 factorial, this is r factorial. I will make the denominators here. See, I want to simplify. What is that I want here? N plus 1 CR I want. So somehow I must rearrange things, do manipulations, and then get the results. For which what I do first now is I try to make the denominators equal. What is that I am going to do? Try make the denominators equal. Now you see that if you compare this r factorial and r minus 1 factorial, this r factorial is r minus 1 factorial into r. That means what? It goes up to r factorial. Before that you have got r minus 1. 1, 2, 3, 4 up to r. That is r factorial. But before r it is r minus 1. So you can write it as r minus 1 factorial into r. So this is r minus 1 factorial. Multiply this by r, and when you multiply this by r, you multiply this also by r. You multiply both sides by r. So what is that I have done here? So you see that it is your r, I multiply this by r and denominator also by r. So r and r will go off, and therefore this ratio does not change its value. Okay, now likewise. Now if you compare this n minus r and this is n minus r plus 1. whereas this is n minus r. Now you see that this n minus r, it is, if you write this n minus r factorial r, before that it is n minus r, then n minus r minus 1. So you see that if you compare these two, this is n minus r, then comes n minus r plus 1. That means what? Here n minus r factorial, then comes n minus r plus 1. Okay, so you see that your n minus r, so up to this if you write this is n minus r plus 1 factorial. So n minus 1 r plus 1 factorial can be written as n minus r factorial into n minus r plus 1. You can write like that. Same as this. Now here you see that here n minus r is there. If you compare these two, this is nothing but what? Here it is nothing but, this place is nothing but n minus r plus 1. N minus r plus 1. So this is bigger than this. This is bigger than this. So you see that here this, if I multiply this by n minus r plus 1 and also divided by that, then n minus, here I have written n minus r factorial already there. If you multiply it by n minus r plus 1, these two combined will give you what? N minus r plus 1 factorial. So what I will do here is that I will multiply this by n minus r plus 1 and also divided by what? N minus r plus 1. So the value of the fraction is not altered, but I do all mathematical manipulations I do in order to see that I get the numerators, denominators the same. So what is that I have done here? I have not done big things. I am doing all manipulations or mathematical jugglery I am doing to get my result, which is on the right hand side, n plus 1 C out. Now you see that. So what is that I have written here? Here multiply it by 4, this one. Now you see that I will rewrite this n factorial or n factorial divided by n minus r plus 1 factorial or into r minus 1 factorial into r, plus you write this as n minus r plus 1 into n factorial divided by, I'll write this as n minus r factorial n minus r plus 1 into r factorial. Now what is this? R minus 1 factorial into r is your r factorial. What is this? N minus r factorial into n minus r plus 1 is what? N minus r plus 1 factorial. Are you able to understand? As I told you, 1, 2, 3, 4 means you can write this as 3 factorial into 4. That is what I have written here. See, 3 factorial into 4, that means 4 factorial. So this is what I have. Now what I will do here is that, so what is that you will get here? So this is equal to r n factorial, then this is nothing but n minus r plus 1 factorial, this can be written as r factorial, plus it is n minus r plus 1 into n factorial divided by this what? This and this will give you what? N minus r plus 1 factorial into r factorial. Now you see that this is also n minus r plus 1 factorial, r factorial. This is also, so take that outside. 1 by n, I will rewrite this as n plus 1 minus r. Then I will write this as r factorial. Take what are things on inside? N factorial is common. So write this n factorial. Here it is left out is n plus n minus r plus 1. So what is that I have done here? N minus r, say I am writing this as n plus 1 r, n plus 1 minus r factorial, then n factorial is common outside. Inside the bracket you have got r plus n minus r plus 1. Now you see that minus r and plus r will get cancelled, giving you what? N factorial into n plus 1 divided by n plus 1 minus r into factorial into r factorial. So this is what do you have here. So you see that as I told you, n factorial into n plus 1. What is it equal to? N plus 1 factorial. Divided by, you take this as n plus 1, I will put it like this, minus r factorial into r factorial. So this is 1. So you take this, you call this as 1. If you see, if you call this as n plus 1, I will write here. So one more step, you will get the answer. So you see that what is that? What is that you get on simplification? So this is equal to, it is nothing but n divided by n minus r into factorial. Now, what is this? Is it not your NCR? N factorial divided by n minus r factorial into r factorial. But what is your n here? N plus 1 CR. This is nothing but your. So, we are able to prove that the left hand side is equal to right hand side. So, this is a very important one, and this is often this is being asked in university examinations for engineering students, for others also. So take care of this and you will get this. I will do one more problem and see that it is over. So see, so this is all about this problem. See, you're asked if, see, let one zero, then the least positive integer k for which so 4 answers are given to you. You have to pick the correct one. So you see that here you see that here given, see, given k n squared minus 1 squared n squared minus 2 squared dot dot dot, it is n squared minus n minus 1 whole square is equal to r square. This is what is given, and of course the n value is given to be 2019. Let us not bother about that, any number let it be there. So you see that here this can be written as k into n, and this can be written as n plus 1 into n minus 1, and the next one is n plus 2 into n minus 2. Like that it goes on, because n squared minus 1 squared is n plus 1 into n minus 1. n squared minus 2 squared, this is 2 squared. It is n plus 2 into n minus 2. So the last one will be n squared minus n minus n minus 1 into n plus n minus 1, n minus n minus 1, n plus n minus 1 is equal to r squared. This r squared is a positive integer. Now what I will do here is that I will write like this, k n keep it like this, and n minus 1, n minus 2, dot dot dot. Here when you come to this place, can you see this? Take this, remove this, n minus n plus 1. So you see that n and n will get cancelled, giving you 1. And before that, n minus 2 means it will be 2, it will be 3, it will be 4, like that it goes on, and it comes to what? So it is increasing, ascending, 1, 2, 3, 4, 5, 6. If you take like this, it's a descending. n minus 1, n minus 2, n minus 3, n minus 4, 4, 3, 2, 1. So this is what you have here. Okay. Now, let me come to this. What is that you are having here? Come to this. The other one is, see, into actually n plus 1. See, here it is n plus 1. It is n plus 2, dot 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 dot. So you see that n plus 1, it is increasing by 1, n plus 2, n plus 3, n plus 4. Finally you get what? N plus, you open the bracket, n. So the final thing is 2n minus 1. This is equal to your r square. So what is that you get here? So you arrange this. Now if you start rewriting this, so what is that I have got here? N plus 1, after then n plus 2. It is ascending. N plus 1 into n plus 2 into n plus 3 into n plus 4, and it goes on like that, and finally he has given to be what? N plus n minus 1, that is 2n minus 1 you are having, that is given to be equal to your r square. Now if you rewrite this x again, start like this. See what I am telling you, from this you write 1, 2, 3, 4 up to, it goes on increasing, and it is n minus 2, n minus 1 into n. Then it is increasing, 1 plus 1, then n plus 2, it goes on up to 2n minus 1, that is equal to r square. Now you tell me, what is this? What is this? 1, 2, 3, 4. 1, 2, 3, 4 means 4 factorial. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 means 10 factorial. So what is it you are having here? 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes up to 2n minus 1. See? It goes up to 2n minus 1. So what is that you will get if it is 2n up to 1, 2, 3, 4, 5, 6, up to 2n minus 1 it goes. So what is that you will get here? So you will get this to be what? So you will get this to be, so you will get kn into 2n minus 1 factorial. So this is what you will have as r square. Okay. Now, so you see that I am having 2n into 2 kn into 2n minus 1 factorial is equal to r square. Now you see that what happens is here, what does it mean? It is given to be your r factorial. I think it is not r squared, it is given to be r factorial. I am sorry, this is r factorial. Where to write the problem? R factorial, r factorial, r factorial, r factorial. See, right hand side is your not. So in the problem, right hand side is r factorial and not r squared. Now you see that here you are having kn into 2n minus 1 factorial is equal to r factorial. That means what? This must be expressed as 1 factorial. This must be expressed as 1 factorial. 1, that means what? Here I will write here. See, what does it mean? Kn factorial is equal to, let us suppose that it is equal to, let us put it like this. I will give an example. Kn into n minus 1 factorial is equal to r factorial. Now you see that, let me put this here. So you see that kn, okay, here, just an example here. see k, let us suppose that you are having kn into n minus 1 factorial r factorial. Now the question is, what value you will assign for this k, so that this will be here on the left hand side factorial notation is equal to right hand side factorial notation. That means what? When you give k is equal to 1, this will become n into n minus 1 factorial, that is equal to n factorial. So n factorial is equal to r factorial. So you are equating two factorial notations. Now the question is, what value will assign for the constants so that the left hand side factorial notation is equal to the right hand side factorial notation. So here you see that, keep this example. So here you must write this k, what k value you will give for k, so that these two combined is a factorial, that factorial is equal to r factorial. It is very obvious that here, as I told you, this n is equal to value, it doesn't make a big difference here. It is not counting in the problem. Even if it is not given, then also it will be okay. So you see that n is equal to 2. Then now here you see that when you take n is equal to 2, when you take n is equal to 2, it means that what? 2n into 2n minus 1 factorial, which is equal to r factorial. But 2n into 2n minus 1 factorial is what? 2n factorial, that is equal to r factorial. So you see that you are on the left hand side, you are able to get a factorial notation which is equal to on the right hand side. So this can come, 2n factorial can come only when I assign x is equal to 2. So you see that only when you take k is equal to 2, you will get 2n factorial, which is equal to r factorial. So this r factorial can be equated to a factorial on the left hand side only when we assign the value k is equal to 2. Are you able to understand? Therefore, the value of k is equal to 2. So this implies that value of k must be 2. Value of k is value of k is equal to 2. Okay, that is what is given in the problem. It is given to be